Hello and welcome to Data Science Corner. This is video 4 of our PySpark series. So in this video, we are going to talk about StructType and StructField function in PySpark. So the topics we are going to cover is StructType, StructField. Then we'll be using PySpark, StructType and StructField with DataFrame. Then we are going to define nested StructType. Then we are going to create a schema parameter for CSV file. Now, StructType function in PySpark defines the structure of the data frame. So PySpark offers the StructType class from PySpark.SQL.types to define data frame structures. So StructType represents a schema comprising a collection of StructField objects. Essentially, a StructType is a list of fields, each with a name and data type, defining the data frame structure. It supports the creation of nested structures and complex data types. Then we are going to talk about StructField, which defines the metadata of the data frame column. It represents a field in the schema containing metadata such as field's name, data type, and nullable status. Each StructField object defines a single column in the data frame, specifying its name and the type of data it holds. Then we are going to talk about using PySpark StructType and StructField function with data frame. So no matter how you create a data frame, you can specify a custom schema using the StructType and StructField classes. As mentioned earlier, StructType is a collection of StructField objects, allowing you to define column names, data types, and nullability. With StructField, you can also incorporate nested structures, array type of arrays, and map type for key value pairs. Now, defining nested StructType object, struct. So to define a nested StructType in PySpark, we are going to embed inner StructType objects within a StructField definition. Each nested StructType is a collection of StructField objects, creating a hierarchical structure that represents complex data with data frames. Then we are going to create a schema parameter for CSV file. Now let us check this practically how to do it in Azure Data Bricks using PySpark. Okay, now we are in Azure Data Bricks. Let's create a new notebook. Now we are going to define our data. That's data equal to. So as we have discussed in our previous videos, how to create data, right? So it will be a list. Inside the list, we'll be providing tuples. So let it be John. And the age be 25. Let the profession be engineer. Then let's create. Now let us create another tuple. So each tuple inside the list is a row. So John 25 engineer is one row. Now we are creating another tuple. It will be another row. So let it be Priya 22. Let the profession be data engineer. Okay, we have created two tuples inside the list. So we'll have two rows. Let's run this. So we have created this data. Now let us define the schema. Schema equal to name and age, then profession. Let us run this. Let us create the data frame. Let's name it as df equal to, so spark dot create data frame. Inside this, we'll pass our data and the schema. Let's run this. Now let us check our data. df.show. Let's run this. So we have created a table: name, age, profession, John 25, engineer, Ria 22, data engineer. Let us check the schema. tf.schema. Let's run this. So here the name is of string type, age is long type, profession is string type. This is what we did in one of our video, create data frame, where we created a data frame from list of tuples. So here now we are going to define the schema ourselves using StructType and StructField. But before that, we need to import StructType and StructField and the data type we want to mention. So here age is of long type, but we want it to be of integer type. So let us first, let's create another cell. So from PySpark .sql .types import StructType, comma StructField, also integer type, comma string type. So let's run this. So we have imported StructType, StructField, integer type, and strict type from PySpark.sql.types. Now let us define our schema. So in schema, let's write struct type. So as I said earlier, so struct type is a list of struct field. So inside struct type, we are going to provide a list of struct field. Struct field. So our first struct field is name, and name is of data type string type. Let us create another struct field. Here we are going to provide age. Now age is of our data type integer. Then comma. Now we are going to create another struct field. Let's copy this and paste it here. Profession, which is of data type string. Now let us run this. So we are getting an error. Okay, here we need to put true after data type. Here also, let's put true. Here as well. Now let us run this. Okay, we are getting an error. So we are getting an error because string type will be a function. Integer type will also be a function. Then this string type will also be a function. Then run this. Okay. Now let us run this df. Let's run this again. Let's check our data set. So we have created this. Now let's check the schema. See, name is of string type, age is of integer type, and profession is of string type. So we created our schema using struct type and struct field, and we provided the data type which we want for the columns. So now this name column is of string type, age is of integer type, and profession is of string type. Now we can use another function, display. Check our data set tf.display. Let's run this. So here also we are able to check. Now the benefit of using display instead of show is that here see we can directly sort it. Also, there are various functions which we can perform in this table, which we have got using display function, which we are going to check in subsequent videos. So this is how you can create schema using StructType and StructField and give the data type you want for the columns. Okay, this is simple. So now let us create nested columns and nested object. So the same data set here, suppose. So here it is one tuple, right? John 25 engineer. But what if this John, right? This is one single tuple. Now what you can do is we can write John, comma. Let's give him a title, Paul. Paul. Now what we are going to do is we will put John and Paul inside a tuple. So now it's become a nested columns. So John and Paul is, sorry, Paul. John and Paul is, John is the first name, Paul is the last name. Same we are going to do with Ria. So Ria, comma, Sen. Now this become a nested columns and nested objects. Now let's run this. Okay, after this, we didn't put comma. Let's run this. Okay. Now let us create the schema, the same schema which we have created here. Let's check this schema equal to name, comma, age, comma, profession. Okay, let's run this. Now let us create our data frame. Let's copy this. Let's make it df2. Let's run this. Let's check our data. df.show. See here name. We are getting John Paul, Ria Sen, age 25, 22, engineer, data engineer. So we created a nested column. See, inside the tuple, we created another tuple for first name and last name. Same thing we did here. So it became a nested columns and the objects are also nested. Now let's use display function. tf2.display. Let's run this. Now in this arrow, right? Click on this arrow. See, there are two objects, John and Paul. There are two objects, Ria, Sen, age 25, 22, engineer, data engineer. Okay, now let us check the schema. tf2.schema. Let's run this. Okay, so then in the column name, there are two fields. One is of string type, that is first name. Then the second is of string type, age is of long type, and field is profession is of string type. Now let us create the schema for this. So for this nested object, John and Paul, we need to create a separate schema. So what we'll do is we'll name it as struct name. Let's create the schema for this name. So struct type. Inside struct type, we are going to create struct field, list of struct fields, because we need to create a struct field for John. Then we need to create a struct field for Paul. This first name and last name. So struct field. First, let us provide first name. Comma. The data type is string type. Okay. Now, comma. This is for first name. Now we are going to create another struct type for struct field for last name. Let's paste it here. Let's make it as last name. Let us run this. Okay, this is created. Now let us create the schema. Schema, name is at schema1 equal to struct type. So struct type is a list of struct fields. So inside this, let's create our struct field. Name equal to name, comma, and the data type is data type will be, now we are going to provide this name, struct name, for the nested object, because we know that name field, right? Name field is a nested columns. So we created a struct type for the nested column. This struct name we are going to provide as the data type. Now let's copy this again. Let's paste it here. Next field is age, and the data type is integer. Comma. You can use back arrow, create a new line. It will be easier to understand. Let's make it as profession, data type, string. Okay, let's put a new line here as well. Okay, let's run this. Now we have created our schema. We have our data here. This is our data. Now let's create the data frame. So let's copy this. Let's name it as df3 data schema1. Let's run this. Let's check this df3.display. Let's run this. So we got our first name as John, last name as Paul. Here as well, first name as Ria, last name Sen, age 25, 22, engineer, data engineer. Let us check the schema. df3.schema. Let's run this. So here the name is of first name string type, last name string type, age is of integer type, profession is of string type. This is how you can create nested columns and objects and provide the data type using struct type and struct field. Okay, I hope it is clear. Now, in our previous video, we read a CSV file and created a data frame. So in this video, let us now import the CSV file. We are going to read the CSV file. Then we are going to provide the data type of the column names using struct type and using struct field. Now let us read the file. I hope you guys are clear how to read the CSV file from the previous video. So tf4 equal to spark dot read dot CSV. Inside this, let's provide the path of the file, comma, header equal to true. Let's run this. Okay, we have read this file. Now let's check the file tf4 dot so. Let's run this. So here we have employee ID 12, name John Ria, age 30, 25. Let us check the schema as well. tf4.schema. Let's run this. Here employee ID is of string type, name is of string type, age is as well of string type. But we want the employee ID to be of integer type. So what we can do is we can create a schema. We can use add method. So there is a method called .add, which we can do to define the data type in while reading CSV file. So schema will be StructType dot add. Then we need to provide the field name, field equal to first one is the employee ID. Now comma data type. So the data type of employee ID, we want it to be integer type. Let's write integer type. Done. Then dot again. Now let us copy this. So the next field name is name. The data type should be string type. So now we need to put for another column, which is age. See, here also we can put new line. So before dot, here as well we can put, let's copy paste this. Then employee ID we want profession. So age. The data type should be string type. Let's run this. Okay, we didn't put dot here. Dot. Let's run this. Okay, done. So now what we can do is while reading the file, right? While reading this file, we can provide our schema. So let's copy paste this. Let's put it as df5. Now before header, schema equal to the name of the schema we defined. Schema. Let's paste it here, comma. Let's run it. Now let's display the file df5.display. So here is the table, employee ID, name, age. Let's check the schema. 5.schema. Let's run this. So here, employee ID is of string integer type, name is of string type, age is of string type. So this is how you can define the data type using StructType dot add method while reading a CSV file. I hope this is clear. This is all for this video. Thank you.